Welcome back to Boson Buzz. I'm Monty Molecule. Our planet is a blue marble for a reason. Over 70% of its surface is covered by ocean, a vast, restless engine of power. For millennia, we've watched its waves crash, felt its currents pull, and known it holds more energy than we could ever need. But capturing that power? It's been a monumental challenge. The sea is a tough, salty, and unpredictable place. But what if we could stop seeing the ocean as a barrier and start seeing it as the world's biggest, most reliable battery? A battery that never runs out, charged by the moon, the sun, and the spin of the Earth itself. This isn't about familiar tidal dams. This is about learning to tap into the ocean's endless rhythmic pulse in entirely new ways. This is the story of the wave Tamir. Imagine a remote island community or a lonely research station on a stormy coast. For places like these, power has always been a problem. They rely on ships bringing in diesel fuel, expensive, polluting, and unreliable. The ocean that surrounds them churns with enough raw energy to power their homes 1,000 times over, but it's just out of reach. Harnessing the sea has always meant building huge, rigid structures to withstand its brute force. Think of massive concrete barriers for tidal power. It's been a battle of strength against strength, and the ocean usually wins through storms, corrosion, and constant wear and tear. The dream has been to find a way to work with the ocean's motion, not just resist it. That dream is now taking shape, not with walls, but with dancers. The first new dancers are called wave energy converters. These aren't power plants as you might picture them. Some look like giant mechanical snakes floating just below the surface, their flexible, segmented bodies bending with every passing wave. Each bend generates electricity inside. Others look like large buoys that bob up and down, or platforms that seesaw with the swell. Their secret is that they are designed to resonate, to move in perfect natural rhythm with the waves, like a child on a swing pushing at just the right moment. This resonance lets them capture far more energy with far less struggle. Instead of fighting the wave, they join its dance, converting the up and down, back and forth motion directly into clean power. But the ocean's power isn't just on the surface. Beneath the waves, mighty rivers flow within the sea itself, the ocean currents. These are vast, slow, and incredibly consistent flows of water, moving around the globe like giant conveyor belts. To tap this, engineers are deploying underwater windmills, but for water. These are called tidal or current turbines. They look like sleek, futuristic propellers mounted on sturdy poles fixed to the seafloor, placed in the path of these reliable underwater rivers. As the current flows, it spins the blades, generating predictable, constant electricity day and night, regardless of whether the sun is shining or the wind is blowing on the surface. It's the most reliable form of renewable energy we've ever found. Then there's a third, more subtle source: temperature. The tropical ocean has a warm surface and cold depths. This temperature difference is a form of stored solar energy. A technology called Ocean Thermal Energy Conversion, or OTEC, uses this. It works like a refrigerator in reverse. Warm surface water is used to boil a special fluid with a very low boiling point, creating vapor that spins a turbine. Then, cold water piped up from the deep ocean condenses the vapor back into a liquid, and the cycle repeats. It's a slow, steady process, running on the planet's own natural heat gradient. It's not just about electricity either. The cold, nutrient-rich water brought up from the depths can be used to cool buildings nearby or to create ideal conditions for farming seafood. The real magic happens when these technologies stop working alone and start working as a team, woven together into what's called a multi-purpose platform. Imagine a large, floating island of innovation, anchored a few miles offshore in deep blue water. It's not a rigid oil rig, but a stable, cleverly designed structure that gently rides the swell. On one side, lines of those mechanical wave snakes flex and sway with the rhythm of the sea. On another, a sleek seesaw device rocks back and forth. Beneath the surface, it's even busier. Long, vertical pipes descend into the dark, cold depths, bringing up water that's just a few degrees above freezing for the OTEC plant on board. Nearby, on the seafloor, a silent forest of current turbines spins steadily in the perpetual underwater river. And on board this floating powerhouse, the OTEC plant uses the temperature difference to add its steady stream of power to the mix. This single platform doesn't just make electricity from 3 different ocean dances at once, it becomes a full-time energy hub. Its combined power can be sent to shore via a thick underwater cable, lighting up a small town. But the platform's true brilliance is in what it can do with all that clean energy right there on the spot. It can perform a kind of modern alchemy, making green hydrogen. Using a process called electrolysis, it splits the very seawater it floats on into hydrogen and oxygen. The oxygen is released, and the pure hydrogen gas is carefully compressed and stored in large, safe tanks on board. This turns the platform into something even more valuable: a floating green fuel station. Ships, even large cargo vessels, could one day pull up alongside, refuel with clean hydrogen, and continue their journeys with zero pollution. One graceful platform, powered solely by the sea, could therefore power a coastal community and help clean up global shipping, a double victory plucked from the ocean's endless motion. Hydrogen is a fantastic fuel. It only produces water when used, but making it usually requires lots of energy. The floating platform, powered entirely by the sea, can split seawater into hydrogen and oxygen. This hydrogen can then be compressed, stored on the platform, and collected by ships, turning it into a floating green fuel station for the shipping industry. One platform could power a coastal town and provide clean fuel for cargo ships, all while sitting peacefully in the swell. The promise of this is a total transformation for coastal communities and our global energy mix. It means reliable, affordable, clean power for islands and remote areas, ending their dependence on imported fuel. It means a new, massive source of predictable baseload power that can complement solar and wind. And by creating green hydrogen at sea, it offers a path to decarbonize some of the hardest-to-clean industries, like global shipping. We are learning to stop conquering the ocean and start collaborating with it, tapping its endless rhythms to power our future in harmony with the planet. The wave-tamer doesn't tame through force, but through understanding and elegant engineering, turning the ocean's eternal motion into a gift of limitless, clean energy. From the relentless crash of the surf to the silent, mighty rivers in the deep, the ocean is finally giving up its energy on its own terms. The wave-tamer represents a leap from fighting nature to partnering with it, using nimble, smart technology to convert the planet's heartbeat into power. It's a vision of energy independence drawn from the sea itself, promising a cleaner, more resilient future for every shoreline on Earth. If harnessing the eternal pulse of the oceans to fuel our world fills you with hope, please help Boson Buzz dive deeper. Give this video a like and subscribe for more stories of brilliant innovation. I'm Monty Molecule. Until next time, have a safe and curious week.